is a monomial. A monomial is either a number, a variable, or a product of numbers and variables that have whole number exponents. A monomial can't have more than one term, and it can't have a variable in its denominator. So if you take a look at the chart down here, 5 is just a simple number, so that is fine, that's a monomial. X is just a variable, that's a monomial. Negative 7xy, that is a product. Remember, product is the answer to multiplication, so that's all multiplication with numbers and variables, so that is fine. And then we have 0.2g squared, and that has whole number exponents. It has a number, it has a variable, it's all multiplication, and the exponent is a whole number, so that is fine as well. Moving over to the other side on not monomials, we have negative 0.3f to the negative third power. We have to have a whole number exponent, and negative 3 is not considered a whole number. The next one we have is 7y minus h. That is not a product because we have subtraction in there. It has to be all multiplication. We can't have anything else. So that does not work. And then we have 3 divided by c, or 3 over c as a fraction. And the last thing up here in our definition said it can't have a variable in its denominator. And the variable c is in the denominator, so that does not work. So moving down here for a couple of examples. Example 1, determine if the given term is a monomial. So the first one they give us is 3bc. It's all multiplication. It doesn't have negative or fraction exponents. It doesn't have division and a variable in the denominator. So it looks good to me. Yes, I would say this is a monomial. The next one, x to the third power. 3 is a whole number. X is a variable. There's no adding and subtracting involved. There's no negative exponent. There's no fraction. So yes, this is a monomial as well. For the square root of z, that can be rearranged to be written as z to the 1/2 power. And that would give us a fraction as an exponent. And in the above definition, we said we had to have a whole number exponent. So no, this is not considered a monomial. The next one, 6 over r, 6 divided by r. That's a variable in the denominator. So no, that one doesn't work. And our last one here is 8r plus 2. That is not all multiplication. We cannot have 2 terms, so no, that's not a monomial as well. All right, now we have quite a few vocab words to take a look at here. Classifying polynomials. A polynomial can be one monomial or the sum or more than one monomial. Of more than one, sorry, that should say of. So in other words, for example, this up here, this is a polynomial. It's not a monomial because it doesn't have one chunk, it has 2 chunks, but it's still considered a polynomial. Polynomial is an of all of them put together, okay? So binomial has 2 terms. That 8r plus 2 has 2 terms. It's separated by a plus or a minus sign. So this would be a term and this would be a term. That's a binomial with 2 terms. A trinomial has 3 terms. So if we had 8r plus 2 plus x, or we could even do minus x. Okay, a plus or a minus separates the chunks. So this one has 3 chunks. That's considered a trinomial. The degree of a polynomial is the greatest sum of the exponents on the variables in each term. So if we have 8x squared y plus x squared, the degree of this chunk would be 3 because we have a 2 and that y has an exponent of 1 even though we don't write it there. And then this term has a degree of 2. So the degree of the polynomial is going to be 3. It's going to be the greatest degree of whichever chunk has the greatest degree. Standard form is a polynomial written from highest degree to lowest degree. So once you find the degree of each term, you can rearrange it and write it from the highest to the lowest. And then a coefficient is a number being multiplied by a variable in each term. So if we have 3x, 3 is our coefficient. It's that number being multiplied by the variable. Leading coefficient is the same thing. It's a coefficient except for it's that one in the very front once something is written in standard form. So if I have 3x to the 4th plus x to the 3rd plus 2. This first chunk has a degree of 4, second chunk has a degree of 3, and 2 does not have any variable, so it has a degree of 0. So the highest, it's already written in standard form, it's highest degree to lowest degree. And what is the coefficient in the very front? It is 3. So that would be our leading coefficient. Okay. So for example 2, we need to write each polynomial in standard form and then classify it by its degree and the number of terms. So this chunk here, 8ab squared, a has an exponent of 1 and b has an exponent of 2. If we add those together, we have 3, so that has a degree of 3. And then this one, a is squared, it's a 2, and b doesn't have 1 written there, so it's automatically a 1. That's a 3. So we can just leave this the way it is. It's in standard form, 3 and 3. We switch it around, it's fine. Okay, so this is a 3rd degree. And how many terms does it have? It has 2 chunks, so that's a binomial. Okay. This one, 4xy squared. X has an exponent of 1, y has an exponent of 2, so add those together, that would be 3. 3x squared, y squared. X has an exponent of 2, and y has an exponent of 2. Add those two together, we get 4. And 5xy. X is 1 and y is 1, so add those together, we get 2. So now we have to write those from highest to lowest. So 3x squared y squared. Then the 3, the degree of 3 is a positive 4x y squared and positive 5xy. Now, if that was a minus sign in front of that 5, then we would make sure we have to put a minus sign in front of the 5 when we rewrite it, no matter where we put it. We got to watch out for those. And our degree here was 4. The highest degree was 4, so this is a 4th degree. And then for our polynomial name, how many chunks does it have? It has 3 different chunks, so this would be a trinomial. And our last section here is simplifying polynomials. It's putting like terms together. So remember, like terms have to have the same variables and the exact same powers in order to combine them. So example 3 says combine like terms to simplify each polynomial. We need to go through and figure out what is the same. So the first thing that we have is 5r cubed. So I'm going to go through and look for r cubed, just r cubed. I see this one here. So those two would go together. We have 5r to the thirds minus 1r to the third. So that would leave us with 4r to the third. The next thing I see here is a negative r squared s. So I'm going to look through my list here for r squared s. Well, I see this negative 3r squared s. So I have negative 1 in the first circle, and I have negative 3 in the last circle. So that would be negative 4r squared s's. And our last, we have a positive 6. And this one has an exponent, but it doesn't have any variables, so we can simplify that as well. 2 to the 5th power. That would be the same thing as if we had written 32 here. So we have a 32 and we have a positive 6 to add together. That would give us 38. In your last step, if you want to make sure that they're written highest degree to lowest degree, and in this case, we need to flip the red one and the blue one because the red is r squared s. That would actually be a degree of 3. And, oh, sorry, that would be the same as the 4r to the third power, so we can leave it just the way it is. All right, one last example. We have 7a squared. We go through and we look for a squareds. Here is one right here. So I have 7 and I have a positive 1. That would make 8a squareds. Then I have a negative ab. I'm going to look for any more ab. There's one right here. So negative ab and negative 5ab would leave us with negative 6ab. And I have a negative 75 and a positive 5 to the third. So 5 to the third means 5 times 5 times 5. 5 times 5 is 25 times 5 is 125. And that's a positive, that's plus there. So that's positive 125, and we have to minus 75. So that would leave us with positive 50. Go through and check your degrees. Make sure you have highest to lowest. 8a squared would be a degree of 2. Negative 6ab, that would be a degree of 2 as well. So that is fine. That's your final answer.